G'day, I'm Dr. Kev, and welcome to Car Design Workshop. Well, we've been going a while now with this channel, and I thought this would be a good opportunity to answer some of the questions that have been posted on the videos. So to start off with, I've got a question here from the video that involved looking at the speed and acceleration of vehicles from 1950 till the current day. And there's a comment from Andy RRR 0791 who wanted to point out that the 0 to 100 time isn't actually the acceleration, it's the reciprocal of the acceleration. And you're exactly right. If we wanted to get an idea of the average acceleration, we could take that velocity that we end up with and divide it by the time. And then we can plot that versus the power and torque and power to weight and get a clearer idea of how we would see those relationships related to acceleration. Spot on. And here's a graph where that has been fixed, or we're looking at that acceleration. None of the conclusions really change, but it is handy to see how this relationship is a little bit clearer to understand. Now, the next video dealt with choosing benchmarks for Project 171, and there were quite a lot of suggestions that came through on the comments, and here's an example of some that were given. One thing that had become clear is I hadn't clearly given enough love to Italian cars. In that same video, we also had Pina Mina 5238, who made a comment that they too knew Justin Zhang, had found him at the Southern California events. And Southern California is where you'll often find Justin trying to hunt down a little bit of speed. And he wasn't surprised that Justin had an Elise. And there's no question here. I just thought I'd highlight another fan of Justin Zhang. Now, in another video that dealt with the specification of Project 171, there was a little bit of discussion in the comments or suggestions about whether to run a composite tub or a space frame. And I think there were a couple of people there excited about the possibility of seeing the development of the composite tub. And there was a voice of reason about the space frame being a much more straightforward thing to implement, probably end up being done a little bit earlier. Well, jury's still out on this. Hope to be making a video about a composite and space frame chassis design and which would be suitable for this project in a future video. So keep a watch out for that. In the video that dealt with choosing the right engine for Project 171, there are a lot of suggestions of other engines I could have used, and here's a few examples. Now, most notably, there were some suggestions for some other four-cylinder motors, so the Duratec, the Mazda engines, or looking at the Volkswagen Audi group, so a 1.8 or a 2-liter engine there. And I thought, given that there was already the Honda K series in that decision matrix, we didn't really need to have a whole lot of four-cylinder motors. There are quite a few options there that would absolutely suit this car. And I know there was a little bit of annoyance that maybe it was a bit of a bait and switch, and that I always intended to build this car around a Boxer motor and it should have been a Honda instead. Oh well, we'll see what happens. There was a question from Sydney Long 9997 who asked, why is the year not important? And wouldn't a newer engine, such as the G16E, require much more ECU work than a less electronically controlled and older model? And I would expect that programming or electric knowledge would be a factor in this choice. Okay. When it comes to this, the newer engines, especially where you start to go to variable valve timing, they can be a little bit more difficult to work with and program. And that's where the Boxer engine does have a slight advantage. If you go to the earlier models, sort of around the year, say 2000 to 2005, they're not as advanced as they have become, which makes it a little bit easier to program. But you do have some limitations in the ICV rules for Western Australia. So you need to hit certain emissions targets. And if you have an engine from I think it's about 2000 onwards, then you don't really have to do that full emissions test. I'm not overly worried about programming the ECU. I think that's something that I'm relatively used to using, and I will be looking to maybe do an aftermarket ECU like a Motec or a Haltech. There's plenty more to come when it comes to actually implementing the engine, but yeah, you are absolutely right. Consideration of the year is reasonably important when choosing the engine. So thanks for the question. Now, on a more disturbing note, when it came to the video where I was scanned to create a driver model, I had a comment from a Mr. T. Hayward, who may or may not be my brother, who said, to get a good render, you should have worn a bodysuit. And I can absolutely assure you, Mr. T. Hayward, that nobody wants to see this in a skin-tight bodysuit. That might actually break YouTube. At least Phil Memory was quite glad that I didn't strip down to the boxer shorts, but did ask that I would do the break dance at the Formula SAE competition at the end of this year. That's a hard no. Happy to join you on commentary again, Phil, but absolutely not going to be doing a break dance, boxer shorts or no. And for Piggy Animations, where you said it was better than ray gun, well, I don't want to claim that. I'm certainly not Olympic level, but it's great to have more than one Australian breakdancer present. So thanks for your comments. Now, moving on to the video that was dealing with CAD Organisation and part numbering, there are a couple of really good questions there. There was one from Ambrose MCC that was really asking about how do you deal with some of the backup and sending files when you're not using a PDM. So a PDM and version control through that's one of the really big advantages of using those tools. And the questions were, do you intend to create a zip of the project when you have a substantial release of parts of manufacturing? Yes, absolutely. I think that's the easiest way to do this. And as a backup procedure, generally taking a pack and go of the whole model every so often and date that and keep that in reserve. You do end up with more than one copy of the files, but I think that's it's the downside of not using a PDM is that version control. And I would much rather have a slightly messier file system than risk losing some of that data. When it comes to the version control, asked, are you doing a save or save as of the files and changing the reb in the file name and moving on? Yeah, I think that works reasonably well. Then you have, say, your multiple revisions in the past that you can go back to. Now, I would say that's only when you do that big step from, say, a version A to a version B. While you're still in that modeling process and you might be coming to and from that model for a while, I think it's okay to just work with the existing file and just continue to save it as its original name. And then when you've got a fairly sizable change, then that is where you put that revision. Now, there was a question from Salt and Sugar and Sand 6114 that asked if I could talk a little bit more about how organization is done for teams. Now, I've spent a large amount of time around Formula Student and Formula SAE teams. I was involved with the start of the UWA team. I was involved with the start of the ECU racing team, both in Western Australia. And I think that Formula SA, Formula Student, whatever it is, if it's in India, China, wherever you are, it's a fantastic thing for students to do. You get to face some things in and doing that project that you'll never do in a normal engineering degree. And a lot of these questions about team organization, how do you motivate students to do sort of work where you're not paying them, you can't keep them there? How do you make sure that the work is of a sufficient quality? These are fantastic questions. Apart from the fact that you're going to have quite a few people on these teams, all with different motivations. So I will cover a little bit about some of the project management that has been used for Project 171. When I went through and did the CAD organization, I also did a fair bit of work around the project organization as well. I didn't put a video up at the time because I wanted to get onto some of the more technical aspects of the build, but I am going to come back and revisit that. And the techniques that I'm using for Project 171 are sort of a a concise version of what would be used in, say, the ECU racing team. We're very similar techniques. In the video where we introduce suspension design, there are a couple of really good questions. And the most obvious one comes from Neil Orange Peel, who says, "This guy hasn't even modeled the tire tread. What sort of fly-by-night dodgy brothers operation is this?" And I can assure you, Neil, this is the dodgiest of operations. But Neil also went on to ask what was the plan for alignment? And so how would you adjust, say, camber and so on of the car if you were moving from, say, the road to a racetrack? So Neil says, obviously you need quite a lot of adjustment if you want to switch to a full race setup. And that's true. This is really being designed as a road car primarily. For the race setup, some of it might be done in adjustment, but it's not out of the question to even make a different wishbone, say a different upper wishbone or a different lower wishbone, to account for a significant increase in camber when you are going to a race setup. At this stage, I do plan to use shims at the chassis to space out brackets to do the major camber adjustment, which should take care of just about everything we need. And if the bracket is bolt on, instead of doing, say, a different wishbone, you might just do a different bracket. So have a high camber bracket that you can swap out if you're doing that race setup. But it's not really going to be designed for the racetrack. Neil also asks, is there any plan to run anti-roll bars? Simple answer is yes. In fact, last night I was with a couple of ECU Racing alumni. We were having a look at a roll bar design that one of them was doing for a project they were working on. We had some pretty good ideas there, and I think I'm just going to borrow some of what he's done and apply that to the project. It was a really good solution in the end. Neil also asks, is there any consideration of running inboard coilovers? And that does provide a bit of flexibility around the use of rockers, and you can really change the linearity of the spring actuation. There's a lot of advantages to going inboard, not the smallest being that it is actually tucked away, but it does add extra parts, extra complexity, and extra weight. And I really think for the road, it's not worth it. It doesn't add a really big improvement overall. You can move from being slightly digressive rate, which you generally get with a direct acting coilover, and make that slightly progressive. So there are some advantages. And if this car was predominantly built for the racetrack, I think it would be probably the right way to go to put some rockers in there. But at this stage, no, won't be inboard coilovers. Now, when it comes to the attachment of where the damper goes, I had a comment or a question from Tudor Miron, who said would they would look into placing the damper attachment on the lower control arm such that the line drawn through the damper access points aligns with the lower ball joint. Now, I normally would do that, and I think I probably am going to change the design to that. I was playing around with a design that was uploaded by Andre Brown. So Andre Brown provided an open source race car. It's the Reynard inverter that he worked on. There's a lot of really good ideas in that car, and they're that file. I highly recommend you go and check it out. And the ideas that I thought were really good around the upright and the wishbones in particular is that Andre had taken a lot of thought into manufacturing and making sure the left and the right hand components were the same components. So when you have the wishbone like this, you can just flip it over and you have a left or a right hand depending on the orientation. That's really good when it comes to manufacturing and reducing costs. So I was just putting it in there. I had remodeled it. I didn't use the original models from Andre, but I do appreciate those were really good ideas from him. And I absolutely encourage you to check out that design. There's some really good information that he's provided. In the same video, Dead Red Rider suggested maybe looking at a radial mounted brake caliper instead of a dog gear mounted brake caliper. This allows easier adjustment based on the size of the rotors that you're going to use just by putting spacers in there. And I think, yes, it's probably a better orientation for the brake caliper. I did originally start with the dog ear calipers because from a machining perspective, it allows more operations to occur on the single setup. But I think this upright, as I'm starting to design it a little bit more and put a bit more time into it, I think that it's going to have multiple setups anyway. So having a radial machining process to do that brake caliper is probably going to be a minimal change, and overall it will make the braking system better. So I am going to look at that in future iterations of that design. Now, when it comes to suggestions, also had a suggestion from Harry to have a look at different ABS systems. So the Teves MK60 units, without discarding the idea of going an ABS unit. And there was another comment in there about another unit as well. I haven't completely discarded the idea of running ABS. There will be the sensors in the car. So the unit that I've chosen for the wheel bearings does have the sensor inbuilt. So it will be possible to do an ABS system. It's probably not high on the agenda at the moment, but we'll revisit that when I come back to have a look at the braking system in more detail. And Harry also mentioned that I should have a look at the Bilstein AS2 damper series, and saying that you can get individual components for a dry build and shim fill them up yourself on a shock dyno. Really exciting. You know, I do have access to a shock dyno at work, a pretty good one, and have got a fair bit of experience working with dampers before. I've, in the past, been involved with some interconnected suspension systems on both the UWA racing car and the ECU racing car. It was something that I was involved with as a student and also as a faculty advisor. So I do like the idea of looking into mucking around with something custom in that way. Far more detail to come when it comes to dampers in later videos. Now, on the video about calculating suspension geometry and some of the experience that I've had in that past, so really running through the different things that I've applied with analyzing pure kinematics, one of the questions from Sylvester Oziomek, hope I pronounced that correctly, was what's my view on roll center migration? Some say it's beneficial, others that it should be kept within a few millimeters. Well, it's a very controversial topic. A lot of people have written about roll centers in the past and roll center migration. And I think some of that has been written has been a little misguided. I don't overly worry about roll center locations, but I do worry about the angle to the instantaneous centers. So that's a much better measure of jacking. And we sort of dealt with that a little bit in the video on forces and force calculation in the suspension system. If the roll center doesn't migrate very much as you're moving around, then that's a fairly good indication that the instantaneous centers aren't moving around very much either, which is a good thing. But if you are too focused on roll center migration, and in particular, if you're worried about sort of lateral migration of that, any solution that ends up with a roll center close to the ground is going to have massive amounts of roll center migration as that roll center starts to cross the ground. But it's not really that big an issue in real life. I mean, the roll center slightly above the ground means there's slightly average upwards jacking force, and the roll center slightly below the ground means there's an absolute slight jacking downwards, but the force difference between those is tiny. So I would encourage, whenever you're approaching these sorts of things like roll centers and concepts, is start to think through them from first principles and see, does it make sense? And generally around this sort of stuff, if it is confusing and you think about it and you're applying engineering mechanics and it still seems confusing, chances are the concept is wrong. All of working with cars is really just engineering mechanics. It's statics and dynamics calculations. And if you have a really good grasp of that, then you will make sense of just about everything that happens with a car. The only real complexity comes in that the tire is quite non-linear in its force generation. So the tire stuff, yes, that's pretty complicated. But in terms of adding on complexities, like things like roll center migration, I think they do more harm than good. Now, one of my favorite questions so far out of all of the videos was from Daniel Burgraff. I hope I pronounced that one correctly, who said, as you use more or less advanced methods, do you notice that solutions that seem optimal in more rudimentary models were actually fundamentally wrong once analyzed deeper? or does the complexity in the model just create incrementally better results? And I think that's a really good question. It starts to get into the philosophy of how we model systems. And we need to keep in mind that any suspension modeling, any dynamics modeling we're doing is a mathematical model of the real situation. It is not the reality. It's an approximation of the reality. So no matter what we do, we are going to introduce error. Sometimes a simpler model can have a larger amount of error than a complex model that has had good inputs. In answering this question, I think it would be worth looking at a really famous quote from Carveth Reed, who wrote, "It's better to be vaguely right than exactly wrong." And I think you're much more likely to come unstuck applying an overly complex model to a problem than you are in applying a simpler model. When you have a more complex model, there's more inputs, more chances to go wrong. When you have a simple model, you're much more likely to be able to understand the limitations of the model that you have created. And as long as you're not trying to optimize outside of the error that you have, then you're not going to come unstuck. So you can certainly use a simple model incorrectly, but it's much more easy to use a complex model incorrectly. And we see this all the time when we're training people how to use finite element analysis, whether that's CFD or structural analysis, in that you can get to a pretty picture very quickly, but making sure that you've got the right inputs is a lot more difficult. So the right inputs and the right setup. Now, when it comes to vehicle dynamics, you have to look at how accurate is your tire model, and your simulations shouldn't really be any more accurate or simple or more complex than what your tire model is. So if you don't have access to good tire models and good tire data, that's going to very seriously limit what you can do with your simulations and calculations. Now, the other thing that I would like to mention around this is that we need to practice being engineers rather than being sort of science orientated people. And when you're doing engineering, so you're building your own car or something like that, the end goal is to build a car that does the job. The end goal is not to do a really cool simulation. There were plenty of people that built some fantastic cars that had never done any tire testing, that had never used a computer, and were doing these things on drawing boards. So, and there was a focus on testing and using the driver feedback and developing a car, but you can do a lot of vehicle development without applying simulations at all. So just keep that in mind when we're doing these sorts of projects. Now, the last video that I want to have a look at questions from is the video on suspension forces. And there were quite a few questions there dealing with some of the details that have maybe been glossed over in the maths. I am trying to present this in a accessible manner, and I'm not going deep into all of the maths. So some people say Grip Goat, for instance, said, "I wish you'd go into more depth on the maths portion." And I fully accept that comment. There's a few things that I could do in the future where I can try to at least put the images up completely. I will note that there are people that are doing this sort of thing on the maths and so on that have way better explanations of the maths sides of this. I really just wanted to provide a few pointers of where you might look at for some of the maths involved here. But I will keep that in mind for future videos. Now, some of the smaller details about what particular things were, I have answered in the comments. So if you were curious about anything there, I do try to respond to comments in a reasonably timely manner so you can see sort of clarification of that. And we had a question from Sylvester Osiomeg, which was that how many Gs could a car pull? There were a few questions there from Sylvester, but one that was, I think, pretty interesting is how many Gs a car can pull. And that is starting to look at to what load cases might we actually want to do when we're designing for the strength of components. And it's really not just the G forces around a track. We've got to look at things like potholes and uh, hitting a curb and things like that. We still need to make sure that the car's suspension isn't collapsing the first time it hits a serious bump. And these load cases, it's very hard to get information about what car companies are doing here unless you've been working in those companies. And I haven't worked for an automotive manufacturer, so I'm having to try and figure out what some of those load cases are. Now, when it comes to the G-forces that a car can produce, I was grabbing some data from a GT style race car going around a racetrack, so a reasonably high grip racetrack. That's going to end up with Gs that are sort of 1.2, 1.3 Gs without significant aero. Now, that's far more than the car's ever going to pull on the road. So I think that applies a fairly reasonable safety factor to the loads. Now, when we do end up designing the wishbones and uprights to these loads, we apply very healthy safety factors to it. You can usually make the components significantly stiffer and stronger without adding a reasonable amount of weight. So it's not a great idea to make these suspension components barely strong enough. I think for a very small amount of additional weight, you can gain a very large amount of extra strength. And we'll see that in future videos. In the same video, we had Claude Ruel ask, why didn't you include the tire MX? First of all, Claude, welcome to the channel. It's always good to see people that are interested in learning a little bit more about vehicle dynamics and vehicle design. You will note that in that video, I did actually include the tire moments as well as the tire forces. I didn't draw a huge attention to it at the time. I wasn't getting carried away in that video about being about the tire forces. I think there's some really good videos out there about how tires produce their force. I will look in the future at putting something together like that, but I'm certainly not suggesting that in 17 or 25 minutes or whatever the video was that you can explain the whole of vehicle dynamics. But on a note on that MX or the overturning moment, for this car, it's not really that big a deal. The car is very lightly loaded, so we know that the overturning moment from the tire increases as a function of load. The load is very low on this. It also increases as a function of camber. And the camber, and we were looking at really the front of this car, the camber is going to be very minimal. We're only looking 1 degree or less camber on the wheel. We also have quite a narrow tire. This is only sort of a 6.5, 7-inch wide tire that we're planning to use. So you haven't got a wide, high cambered tire with high load. So the MX is actually quite low. Now, if we look at this into suspension loads into the particular links, I can show an example of this. So I can show both a solid and dotted line on this graph. One is with MX, one is without MX, and you can see that the load differences are very small. We see the maximum difference in that pure cornering case, which is what you would expect. Now, these MX loads, they are an estimate. They were based off data provided by a paper from Toyota, so it's a research paper. It's a similar tire. I don't at the moment have access to tire data for the tires that I intend to run, which is a little bit of a limitation when we're starting to do this design work. But I do not expect that MX is going to be a really big concern in this car. Now, if you are running a race car, so especially if it was a high aero, so high aero race car with wide tires and running a lot of camber, and generally at the front end of a car, you might run quite a lot of camber, then yes, MX would be a big concern. But for this, a lightly loaded road car with a fair bit of sidewall on it, no, it's not a big deal. In the same video, Florian Hoffman took a bit of an issue that I was using the Jet color map for MATLAB and suggested that the newer versions of MATLAB have different color maps, one in particular called Perula. Now, I did try a couple of different color maps to try and get the visualization right. I didn't try Perula, but after your suggestion, Florian, I went back and gave it a go, and here it is in Perula. And yes, that's a neater looking color map and still reasonably easy to understand. So I'll take that on the board and try to avoid using MATLAB's Jet color map in the future. Nez7545 asked, how would you create those sick visual diagrams? Wants to steal the idea for a design event. So I'm assuming Formula student or Formula SAE, steal away. Absolutely. I put these up there as ideas for you to maybe use for yourself. And really, to create these visuals, all it was is cylinders. And so I do what any programmer does, is that as soon as I've got a problem, I go and search. And for MATLAB, I go, how do I draw a cylinder between 2 points, and change the colors and then modify the code from that. There's some really good repositories of MATLAB tutorials. MATLAB themselves, so MathWorks, produces a lot of really good content around there. You just have to wade through it and know what you're looking for. But there's nothing really in these visuals apart from colored cylinders. And I've been using colored cylinders like this for years. In fact, we did the same thing when we programmed Optimum K, so the Optimum Kinematics program. It was really just cylinders, fairly simple graphics, but it ends up being quite effective. Now, in general, there have been quite a few comments about where to go to learn a lot of this stuff. So where to start from if you're starting from zero suspension design knowledge, where do you go? What sort of books would you read? Now, there's so many books and resources out there, but I think the place that I'd point you to is in the Formula SAE forums, which is unfortunately a little bit dead at the moment. There is a great reading list, and it's just pages and pages of books that deal with just about every subject on vehicle design. You could go a lot worse than going through that list and just starting to work your way through them. Now, I would note, when you're starting to look at suspension design in particular, some of the books have varying levels of accuracy and relevance. So you just got to read, I think, more than just one or two books. You don't want to be misled. You want to find what things are in common between authors and where the main differences lie, so that then you can start to determine what you think is the right answer there. And definitely always check what you're reading up against sound engineering knowledge. All of the suspension design and so on is really just using basic mechanical concepts. So Newton's laws, sum of forces, all of that. Now, clearly, I haven't been able to answer all of the questions that have been posted, and hopefully some of those were dealt with in the comments of those particular videos, and some that I'll deal with in future videos. I do plan on maybe doing some of these videos where we answer questions on a semi-regular basis, because it allows at least to respond with some visuals rather than just text. So if you do have a burning question of a particular video, make sure you put it in the comments. I do read them, and I do pay attention, and I do intend to try and cover most of that material in either a direct answer or in a future video. Thanks for your time.